In quantum mechanics, total probability must always equal 1. It can never leak away. So the transformations that move states around, time evolution, symmetries, changes of basis, cannot stretch or shrink anything. They must be rigid rotations of Hilbert space. These are the unitary operators. An operator U is unitary if its conjugate transpose is also its inverse. U dagger, U equals U dagger equals the identity. In other words, U dagger equals U inverse. Undoing U is as easy as taking its dagger. Already this tells us a unitary operator is always invertible, and its action is perfectly reversible. The defining feature is this. A unitary operator preserves the inner product. The overlap of U phi with U psi is exactly the overlap of phi with psi. Lengths are preserved. Angles are preserved. And since probabilities are built from inner products, every probability is preserved too. A unitary transformation is a rotation. It turns the whole space, without distorting it. What about its eigenvalues? Because lengths are preserved, an eigenvalue cannot scale a vector up or down. So every eigenvalue of a unitary operator has magnitude exactly 1. It is a pure phase, e to the I theta. The eigenvalues all lie on the unit circle in the complex plane. A unitary operator also carries one orthonormal basis into another. Feed it perpendicular unit vectors, and out come perpendicular unit vectors. Equivalently, the columns of a unitary matrix are themselves an orthonormal set. This is exactly why unitaries describe a change of orthonormal basis, with no information lost. Where do unitary operators come from? From Hermitian ones. Exponentiate I times a Hermitian operator A, and you get a unitary. U equals e to the IA. The most important case is time evolution itself. The state at time t is U of t, acting on the start, where U of t is e to the minus iht over h bar. The Hermitian Hamiltonian generates unitary evolution. So unitary operators are the guardians of quantum consistency. They conserve total probability. They are reversible, because the inverse always exists. And they implement every symmetry. Every rotation, every translation, and the unbroken flow of time between measurements. Smooth, lossless, and exact. Hermitian operators are what we measure. Unitary operators are how states move. One has real eigenvalues, the other eigenvalues on the unit circle. Together, the self-adjoint and the unitary are the two pillars on which the whole machinery of quantum mechanics stands.